Okay, we're now recording. Let me share the screen. I didn't turn on the camera. Start over. Try that again. Okay, so here we are. Try to get this toy working again. I get myself untangled here. All the extra wiring that we have. Okay, so plug it in. Hopefully, it make the audio better. Okay, it's audio better. Sorry, I'm getting all tangled up again. All right, so we're here. So 4.5 and 4.6. 4.5 has word problems. I'll knock those off and then go to 4.6. Tomorrow 4.7 and a quiz. Okay, I'll give you a quiz on the parabola. And today's quiz is probably, in-class assignment will probably have to do with the parabola also. Okay. So we're here. I did a lot of the word problems yesterday, which were applied max and min, right? To maximize and minimize, you find a vertex. The formula was negative b over 2a, you might recall. Okay, so I did a bunch. I'll do some more, then hopefully get started with 4.6. Okay, so let's continue with 4.5. Looks like we had an even problem, number 12. So let's start off with that. Okay. So I'm going to take a quick time out here again to untangle myself. I got my wires a little bit crossed here, so sorry. You know how it is when you have all these wires and you accidentally have all these knots. And so I accidentally made a knot and kind of just twisted myself up. Okay, 12. Find a point on the curve y equals square root of x that is nearest to the point 3, 0. Okay, so y equals square root of x nearest to 3, 0. So how do we do that? Okay, so put today is the what, 17th? Page 267. Okay, y equals square root of x nearest 3, 0. Okay. Let me show you the picture of what's going on. Technically, you can do this without a picture, but let's go ahead and make one anyway. So square root function, you should know, looks something like this. It's 0.30. Okay, so we're asking where is the distance a minimum, right? Distance from 3, 0 to a point on a graph, x, y, which minimizes the distance. Okay. So we have the point x, y, but since y is equal to radical x, I can write it as x, radical x. Okay. And then I use the distance formula. Okay. So a long time ago, we had a distance formula where distance squared is x2 minus x1 squared plus y2 minus y1 squared. It's basically the Pythagorean theorem. Okay, you could draw yourself a right triangle here and so forth. Okay, but let's just use that here. So distance squared is, okay, so I subtract the x's, x minus 3 squared plus subtract the y's, radical x minus 0 squared. Okay, so that's a distance formula. We had that a long time ago. If you want to put this on your cheat sheet, you may. Okay, so x minus 3 squared plus radical x minus 0 squared. So I can write it as f of x. So I will square this, x squared minus 6x plus 9 plus square root of x minus 0 is square root of x. What's square root of x squared? Just x. So that's x squared minus 5x plus 9. And there we go. I want to minimize this. Right? Okay, it's a parabola opening up, which means the vertex would be a minimum. Am I looking for a minimum? Yes, I am. Okay, so the vertex formula is x equals negative b over 2a. Again, put that on your next cheat sheet for the exam, which is next Thursday. We call the next test is a week from tomorrow, I guess it is, right? 25th. Covering chapters 3 and 4, which I'm almost done with. Okay, so again, next week I'll start chapter 5, but that won't be on the test. The test is chapters 3 and 4. Okay. So right over here, right? Okay, so negative b, negative 5. It's 5. Over 2a, 2 times 1 is 2. So x is 5 halves. Okay, what's the y coordinate? Well, the square root of 5 halves. I'll just leave it like that. So the answer is 5 halves, comma, square root of 5 halves. Okay, so that's the point on the graph for which the distance away from 3, 0 is the minimum. Okay, so you say, how do I go toward this so that I minimize the distance? It'd be 5 halves, comma, square root of 5 halves, which is over here somewhere. Okay. All right, so that's how that one works. And I'll raise it up again so you can see what's happening. Okay, so that was question 12. I should have written that down. Question 12. Okay, then what do we have? 17, 19, 23a. Maybe I'll just go ahead and try to knock them all off, or at least set you up with it. 17, 500 feet of fencing is available for a rectangular pasture along a river. The river serving as one side of the rectangle, so only 3 sides require fencing. Find the dimensions using the greatest area. Okay, so we have 500 feet for 3 sides. Okay, so I'll call that X. This is also X. This is Y. You don't need fence over here, supposedly. Okay, so the total amount of fencing is 500 feet. So I have X plus Y plus X. That's 2X plus Y equals 500. 500 feet. Okay, solve for Y. Y is 500 minus 2X. Okay, so you want to maximize the area. What's the formula for the area? Well, base times height. So area equals X times Y. But what is Y? I pick this up and throw it in here. X times 500 minus 2x. So as a function, a of x is negative 2x squared plus 500x. Okay, and you want to maximize this. Okay, and I think I'll let you take it from there. So I'm going to say et cetera. Now, of course, you don't get to say et cetera on homework or quizzes or tests. I get to say et cetera, but you guys don't get to say et cetera. Finish it. Okay, this is a parabola opening which way? In. There's a -2. The A is negative. So that means it's going to open down, which means the vertex is a maximum. So do the negative b over 2a stuff, and that will get you what you need for 17. Okay, so just do the negative b over 2a. That'll figure out the x. Once you have x, plug in to find y, and that gives you the dimensions. Okay. And yeah, the question asks for the dimensions. Number 17, find the dimensions. So your answer is so many feet by so many feet. So your answer is blah, blah, blah feet by blah, blah, blah feet. Just figure out what that is. Okay. Okay, then 19 and 23a, then we're just about done. So let's see, 19. 19, let R equal blah, 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 C equal blah, 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 for which value of X is R minus C a maximum? Okay, so you have two functions, you want R minus C. So let me write all this down. So R is equal to 0.4x squared plus 10x plus 5. C is equal to 0.5x squared plus 2x plus 101. Maximize R minus C. Okay. This is basically a problem in economics. R is revenue. C is cost. What is revenue minus cost? Profit. Okay. So, in economics, how much money am I making as a business? Well, revenue minus cost. How much money is coming in minus how much do you have to shell out? Okay. So the profit is revenue, 0.4x squared plus 10x plus 5 minus, I'll line it up, 0.5x squared plus 2x plus 101. Okay. So this is the revenue. This is the cost. Has to be in parentheses. And the nice thing about lining up like this is you can tell right away, oh yeah, it's that minus that, that minus that, that minus that. Okay, so the profit function is 0.4 minus 0.5 is negative 0.1x squared. And then 10x minus 2x is plus 8x. And then 5 minus 101 is minus 96. Okay, and we're trying to maximize this. Right? Okay, this is a parabola opening which way? Hint, there's a negative for A. Opens down, which means the vertex is a maximum. Are we looking for a maximum? Yes, we are. Okay, so formula for the vertex, x is negative b over 2a. So negative b is negative 8 over 2 times negative 0.1. 2 times negative 0.1 is negative 0.2. Okay, negative divided by negative is positive. 8 divided by 0.2 is 40. So the answer is x equals 40. That's all they asked for. 19. What value of x is r minus c a maximum? So we gave it to them. X is 40. So we're done. So we maximize the profit as x equals 40. Okay. Okay, and then 23A, and then I'm done, and I've just about almost literally did the entire section because I know they were word problems. They're a little bit harder if I left you, to your own devices. So I said, okay, I'll either do just about all of them or set them up. Okay, so let's see what 23A is about, and then I can get started with number 4.6. So 23A, what does it mean? Find the smallest possible value of the quantity x squared plus y squared under the restriction that 2x plus 3y equals 6. Okay, so how do you do that? Two x plus 3y equals 6. And you're trying to minimize x squared plus y squared. Okay, so let's first solve for y. So move that over. 3y equals 6 minus 2x. Divide by 3. Y equals 6 divided by 3 is 2 minus 2/3 x. All right, so you want to minimize x squared plus y squared. Well, we now know what y is. Y is this thing, 2 minus 2/3 x quantity squared. Okay, and now just clean up the algebra. So say f of x is x squared plus, okay, so again, that looks like a minus b squared, right? That's of the form a minus b squared. So it's 2 squared, which is 4, minus 2ab. Okay, so remember this is a squared minus 2ab plus b squared by shortcut. So minus 2 times a times b. 2 times 2 is 4. 4 times 2/3 is negative 8/3 x plus b squared. 2/3 x squared is 4/9 x squared. Okay, the coefficient of x squared is 1. I'll show you how I'm going to write 1. Nine over 9 is 1, right? So 9 over 9 plus 4 over 9 is 13 over 9. 13 over 9 x squared minus 8/3 x plus 4. And again, I'll just say etc. You're trying to minimize this. Okay, and basically I'm done. You do have a very messy a and b, but you can live with it, hopefully. A is 13 over 9. B is negative 8/3. Plug into x is negative b over 2a. Okay, and a quick word. Let's see, the coefficient of x squared is positive. Positive means parabola opens up, which means vertex is a minimum. Are we looking for a minimum? Yes, we are. So again, everything works out the way it's supposed to be. If it's supposed to be a maximum, it'll come up to be a maximum. If it's supposed to be a minimum, it'll come out to be a minimum. So we're fine in that respect. Okay. All right, so I can now knock off 4.5. And the rest of today, I just have 4.6. It's only about 11:35-ish. So I think we'll be good time-wise. Right. So 4.6 is graphing polynomial functions now. So I'm going to start that. Okay, so 4.6, polynomial functions, page 274. Okay. Now, you should already be somewhat familiar with the basic functions on page 275. Okay, they've got y equals 1, horizontal line, y equals x, straight line, y equals x squared, x cubed, 1 over x, square root of x, right? Okay. Now we're going to look at other functions that are similar in nature right now. So let me show you that. So we're doing polynomials. Okay, turns out if I have an odd exponent, x to the 1, x cubed, x to the 5th, x to the 7th, and so on, okay, they all tend to look something like this. Okay, we've already seen x cubed. Well, x to the 1 is a straight line, but all the others curve like this. To go through quadrants 1 and 3, if you plug in a positive, you get a positive. If you plug in a negative, cube it, you also get a negative. Okay. If you have an even exponent, x squared, x to the 4th, x to the 6th, x to the 8th, and so on, they all tend to look something like this, just like the parabola. Okay. In fact, there's a name that we can give to some of these. These are odd functions. Kind of makes sense. Although there are odd functions that don't look like this. So I'll give you a formal definition of odd and even functions shortly. These are even functions. Okay, it looks like for even functions, we have symmetry with respect to the y-axis. Odd functions, we have symmetry with respect to the origin. Okay, so odd functions origin symmetry. Even functions, y-axis symmetry. Okay, that's going to be true for all odd functions. That's true for all even functions. Now, there are odd functions that don't look like this. There are even functions that don't look like this. It's very natural to call these even functions because the exponents are even. Likewise, these are odd. Okay, but now we want to give a very formal definition of odd and even functions. Okay, okay, let's take a look at, let's say, x cubed. What do you get if I plug in 2? 2 cubed is 8. How about if I plug in negative 2? Negative 2 cubed, negative 2 times negative 2 times negative 2 is negative 8. You get the opposite. Okay, how about if I plug in 3? 3 cubed, 3 times 3 times 3, 27. Negative 3 cubed, negative 3 times negative 3 times negative 3, negative 27. Okay, so when you plug in the negative of the number, you get the opposite of what you would have got if you plugged in a positive. Okay, so here's a characteristic of odd functions. f of negative x is the opposite of f of x. Okay. In fact, this is going to be now used as a definition of an odd function. A function is defined to be odd if f of negative x is the opposite of f of x. Okay, that's true for these, but there are other functions that don't look like this, okay, but they're still considered odd if they have this property. Okay, how about for even functions? Okay, let's take a x squared. I could take x to the 4th or 6th or 8th, but x squared is easy. Okay, what do you get when you plug in 2? 4. What do you get when you plug in negative 2? Still 4, right? Because you're squaring it. How about if I plug in x squared? How about I plug in 5? 25. Plug in negative 5. Still 25. Get the same thing back. Okay, so for even functions, f of negative x is the same as f of x. If you plug in the negative of a number, you get the same result as the positive of a number. Okay, so that's a characteristic of even functions, although we will see some functions that are even that don't look like this as time goes by. I'll show you some examples of those. Okay, so basically x to the 1, 3, 5, 7, they all go like this. They pass through quadrants 1 and 3. If you want to put this on your cheat sheet, you may. Even functions, or the even powers, x squared, 4th, they all kind of look like that. Okay. We know how to translate. So on page 281, the blue graph is x to the 5th. Okay, x to the 5th kind of looks like x cubed, x to the 7th. So quickly, something like that. Okay, just a rough and dirty sketch. And then in red, they changed x to x plus 2. X plus 2 to the 5th, move the graph 2 to the left. So instead of the origin 0, 0, notice it goes to negative 2, 0 over here. That's the kind of thing you want to kind of get used to. Okay, so not just plotting a whole bunch of points, but just starting with a basic graph and then moving left, right, up or down or whatever. Okay. Figure 10, negative 2x to the 4th. Okay, positive 2x to the 4th would go up. The negative makes it go down. And then look over here. What's the difference between figure 10A and B? They moved the graph 3 units to the right because x got replaced by x minus 3, right? So notice the few points that they have, they moved everything over 3 to the right. So the origin 0, 0 got moved to 3, 0. Negative 1, negative 2, if you move it 3 to the right, you have 2, negative 2. 1, negative 2, move it 3 to the right, becomes 4, negative 2, and so on. Okay. So we have our translation rules just like before. Okay. Then it's going to be a little bit harder if you have these, and I'll show you how to do problems of this nature. It kind of piggybacks on stuff that we've already done. Okay. Now polynomials are always smooth. Okay. In calculus, we would say they're continuous, right? There's no breaks, there's no gaps. Okay. They don't even have any kinks like corner points. Okay. No cusps, something like that. It's never broken like that. You'll study that when you get to calc. Okay. But they're always smooth, sort of like stuff like that. Okay. Because one way you can think of it as if you build roller coasters, you want a roller coaster to look like that. Okay. You don't want a roller coaster to look like that. That doesn't seem right. Right. You don't have that. You definitely don't have that. Right. You can't just go here and then fly up to go to that point. They don't build tracks like that, at least not yet. Okay. Where somehow the roller coaster that you're on, you can fly up to another point. You know, we don't have that yet, but okay, if you're on a track, it's all smooth and continuous, as we would say. Okay. All right, so what are we trying to do? Is what time is it? 11:45. Okay, I think we're good. Okay, so we're aiming for what? 5 to 15 odd, 27 to 43. Okay, so let me start off with 5 to 15. Those are the easier ones. And then 27 to 43 a little bit harder. Okay, and let me check a question in the chat. Okay, so I think I'm caught up. Yeah, okay. Okay, sketch the graph of each function, specify intercepts. Okay, 5 through 15, so I'll do some of those. Number 5, y equals x minus 2 squared plus 1. Okay, so we've seen that before. Y equals x squared. And then this moves 2 units to the right, 1 up. Okay, so 2 right, 1 up. Okay, again, this one is counterintuitive. When you see the minus, you might think, oh, I'm going left. You're actually going right. So the easiest thing to do is just move the origin. So 0, 0. If I move 2 to the right and 1 up, I'm at 2, 1, correct? So I'll just quickly draw another parabola where the vertex is 2, 1. Right? All right, then it asks for intercepts. Well, there is no x-intercept, right? Doesn't touch down here. Y-intercept means x equals 0. 0, comma. Okay, so let's plug in 0. F of 0. 0 minus 2 squared plus 1. Negative 2. Negative 2 squared is 4. 4 plus 1 is 5. So 0, comma 5 is the only intercept in this particular case. Okay. How about I'll show you number 11. Negative 2 times x plus 5 to the 4th power. Okay, so quick and dirty graph. Okay, we know x to the 4th falls into this category, right? So here's the progression. Okay, just a rough sketch. Okay, now how about negative 2 x to the 4th? Okay, the 2 makes it narrower. Okay, so instead of like this, it'll go more like so. And the negative would reflect across the x-axis. Okay, so I make it go upside down but narrower. There's negative 2 x to the 4th. I suppose if you wanted to, you could even just put, 2x to the 4th. Okay, I'll sneak it in. You don't have to in this case, but for teaching purposes, I'll show that. So now the picture is getting a little bit cluttered, but this is 2x to the 4th. Okay, so it shoots up to infinity faster. So it kind of goes like that. That's 2x to the fourth. Then reflect across the x-axis. It goes like that. Okay, then what about that? You replace x with x plus 5. That moves the graph 5 units to the left. Okay. So now I move 5 to the left, and I think the picture is going to get too cluttered. So I'll just make a new graph where this thing gets shot over 5 units. Okay. Yeah, if you do this for me, don't feel like you have to put all the graphs on one. The picture might get too cluttered. So I'll just move over and have something like this, let's say. And label a key point. That was 0, 0. If I move 5 to the left, this is now -5, 0. So that's what I got. Y equals -2 times x plus 5 to the 4th power. All right, ask for the intercepts. Well, here's an intercept already, -5, 0. And there's one over here, which is 0, comma something. So what is the something? I plug in 0. So f of 0 is -2 times 0 plus 5 is 5 to the 4th power. And that's a really big negative number. Okay, so 5 to the 4th, 5 times 5 times 5 times 5. You can just use your calculator for something like that. So that comes out to be 625. And -2 times 625 is -1250. So this is not even the scale. It's actually way down here, but that's okay. So -1250 is what I'm going to put there. Okay. Okay, how about I'll do 13 and maybe that's it and then we'll break. And that's a natural break because these problems are different than these problems. These work out a little bit differently than these. Okay, so 13, please. In case you didn't catch these. Just raise this up again so you can watch the video later. 19, in case I didn't get to raise it up for focusing purposes. There's that and that. Okay. Okay, what do we have for 13? X plus 1 to the 5th power divided by 2. Okay, I'm going to treat it as 1/2 x plus 1 to the 5th. It's the same thing. Okay, so I'm going to start off with x to the 5th. Okay, x to the 5th, odd, so it goes through quadrants 1 and 3. Okay, now let me do the half. Now the previous one, we multiplied it by 2, so it shoots up toward infinity faster. What happens if I add half? It goes slower. So it's going to be lower on this side, higher on this side. Okay. So the green, if you can see that's green, is 1/2 x to the 5th. And now what about this? Move 1 unit to the left. Okay, so move 1 left. And yeah, since I have different colors, I'm willing to go ahead with it. So I'm trying to duplicate the green, but shift it over 1 unit to the left. So the final answer is to red, 1/2 x plus 1 to the 5th power. And just give these intercepts. So that's -1, 0. Okay, it used to be 0, 0, right? So move to -1, 0. And what does that intercept? Well, x is 0. So put a 0 there. 0 plus 1 is 1. 1 to the 5th power is 1. 1 times 1/2 is 1/2. So this point, and picture's getting cluttered up here, so I'll draw an arrow. This is 0, 1/2. So those are all the intercepts. Intercepts means where does it touch the x or y axes. So -1, 0, and 0, 1/2. And there we are. Okay, so that'll do it for that. Let me check the chat real quickly. Okay, so that's fine. So let me just type that. Okay. So if I can get that here. Okay, I answered somebody's chat. So I think we're good now. Okay, so we'll go ahead and take a break now. So I'll stop the share. I see it's 11:56. So let's break until 12:10. Okay, so break till 12:10. I'll type that in the chat also. Okay. Okay, folks, it's 10 after, so I'm going to go ahead and get started. Okay, we're going to graph sum of 27 to 43. Okay, then after I feel like I've done enough, I'll give you an in-class problem involving parabolas. For tomorrow's quiz will also involve parabolas. Okay, so hopefully it's not too bad from there. Okay, so 27 to 43, and let me show you the directions. I'm changing it completely. Okay, in the directions, they ask you to do all this stuff. Just graph it, okay? So just do part B, graph each function. Same thing over here. See A and B, forget all that, just do part C, graph it. Okay, which also reminds me, maybe I didn't show you the problems. So for those of you that don't have the book and don't plan to get it, okay, and if I ever do that, remind me if you're one of the people that aren't getting the book and I never showed you. If I forget, then remind me and I'll get it for you. So let's see, 5 to 15, odd, there's that. And then 27 to 43. Okay, graph and graph. Okay. Most of these were piggybacking off of some information that we've already learned before. So I'll show you how to graph these now. Okay, so start with something like 27. Y equals x minus 2, x minus 1, x plus 1. Okay, now you don't have to write this down, but for polynomials in general, okay, they're always going to go either to infinity or negative infinity in the long run. Okay, so if I go way out there, it's either going to shoot way up or it's going to shoot way down. Okay, so if I go toward positive infinity, the graph goes either to positive or negative infinity. Likewise, if I let x go to negative infinity, y is either going to shoot down or shoot up. Okay, you don't really have to write that down. It'll become obvious, quote unquote, when I start doing some problems, and you'll see what I have here. Okay, so how do I graph this? First, let's just get the zeros. Okay, so these zeros, now let's pretend this is 0. So x equals 2, 1, and negative 1, right? What makes that 0? 2. What makes that 0? 1. What makes that 0? Negative 1. So right now on the graph, I'm just going to go like this. Okay, negative 1, 0, 1, 0, 2, 0. Okay. Now, what about all the rest of the part? Well, nowhere else is going to be 0, so it's either going to be positive or negative. So we just check for positive or negative. We've actually already played this game before, but not in a two-dimensional graphing scheme. So I just pick a number over here, pick a number over here, pick a number over here, pick a number over here. Just like the regions I had before. Region 1, how about negative 2? Region 2, 0. Region 3, 1.5. Region 4, 3. Remember doing this kind of stuff before? Okay, and let me rewrite this so it's closer. X minus 2, x minus 1, x plus 1. Okay, remember the context we had before was positive, negative, and then we said true or false. Here we're still going to say positive or negative, but we're not going to say true or false. It'll just tell us whether the graph goes up or down. Okay, so I'll show you what I mean. Okay, plug in negative 2. Negative 2 minus 2 is negative. Negative 2 minus 1 is a negative. And maybe I should line these up, but I wanted to save space. Negative 2 plus 1 is negative. Negative times a negative times a negative is negative. So that means to the left of negative 1, the graph is negative. And it's either going to go to infinity or negative infinity. So that tells me it shoots down like that. Okay. Do the same thing for 0. 0 minus 2, negative. 0 minus 1, negative. 0 plus 1, positive. 2 negatives and a positive, positive. That means in region 2, the graph is positive. So it goes up and then comes down. Get the idea? Now, I don't really know how high it goes up. Maybe it goes way up here and comes down. Right now, we aren't able to determine that. When you get to calculus, you'll determine, how high does it actually go. All we can say right now is it goes up and comes down. Okay, between 1 and 2, 1.5. 1.5 minus 2, negative. Remember doing this game before? 1.5 minus 1, positive. 1.5 plus 1, positive. So I have a negative times a positive times a positive. That's negative. So that means it goes down and comes back up. Okay. Now, I'm going to draw it like this. I don't really know. Maybe it comes way down here and then goes up. We don't know. So for now, just something like this. And then 3. 3 minus 2, positive. 3 minus 1, positive. 3 plus 1, positive. Positive times positive times positive, positive. So it's above. And since this is the last 0, it shoots up toward infinity. So there's the graph. Okay. Once you're at past the last 0 on either side, you're either going to go to infinity or negative infinity. So over here, right? Once I knew it was negative, it shoots out a negative infinity. If it goes up, then it would shoot to positive infinity. Same thing over here. I reached the last 0, which is 2. So if I knew it was negative, it's going to shoot down to negative infinity. And here I knew it was positive, so it shoots up to positive infinity. Okay. Now, if you understood this problem, all the rest of the problems are just like it. Same style. The only extra complication is you might have to factor. Okay, and I'll show you where you might have to factor. So that makes it a little bit harder. So let's see. A little bit tougher one might be, say, 33. I'll try to pick the hardest one of the bunch. But 27, 29, 31, 30, they all pretty much work the same way. But 33 looks like it's the hardest to factor. So let me do 33, okay? X cubed plus 3x squared, blah, 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 blah. X cubed plus 3x squared minus 4x minus 12. Okay, so I have to try to factor this. Okay, do you remember something called factoring by grouping in algebra? Okay, I will factor this pair and this pair. Right, group them. So just for these two, common factor, x squared. And then x plus 3. And common factor here, negative 4. X plus 3. And now we have a common factor of x plus 3. Pull that out. Left behind is x squared minus 4. And hopefully you recognize x squared minus 4 is x plus 2, x minus 2. Okay, so there we go. All right, so I've made this problem look like this, in other words. The hard part was to get it to be like that. Okay, so this is called factoring by grouping. You might recall factoring by grouping. So you pair them. Factor here, x squared. Factor here, -4. They have a common factor of x plus 3. Pull out the x plus 3. You're left behind x squared minus 4. That becomes x plus 2, x minus 2. Okay, so what are the zeros? Zeros means what makes y equal to 0. So x equals -3, -2, and +2. Okay, so I put those on my number line and go from there. So let's see, -3, -2, and 2. -3. Okay, I'm not even putting any y coordinates. It doesn't really matter. So here's -3, here's -2, and here's +2. So 0 there, 0 there, and 0 there, right? If you plug in -3 for all of these, that'll become 0. 0 times anything is 0. If you plug in -2 here, here, and here, -2 right here makes this 0. So then multiply by the rest, you get 0. And +2 gives me 0. If I plug in a 2 here, here, and here, well, this 2 minus 2 is 0, so 0 times all that is 0. So now just determine, does it go up or down at each? Okay, and yeah, let me rewrite the expression that we have. It was x plus 3, x plus 2, x minus 2. Okay. All right, pick something here, 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 and here. I'll call them regions 1, 2, 3, and 4. Now you might recall when I did this before, I put 1, 2, 3, and 4 here also, but I don't want to do that here because it'll clutter up the picture. So I'm just going in order. You know, that's 1, 2, 3, and 4. Okay, region 1, how about -4? Region 2, -2.5. Region 3, 0. Region 4, 3. Okay, and just do the same thing. Plug in -4. -4 plus 3, negative. -4 plus 2, negative. -4 minus 2, negative. 3 negatives multiplied together, negative. Now before when we did it, we said true or false, all right? But now it's either positive or negative, and you're going to graph no matter what. So this side it's negative, and there's no zeros to the left of this, so it shoots down to -infinity. Okay, -2.5 plus 3, positive. -2.5 plus 2, negative. -2.5 minus 2, negative. A positive times a negative, positive. So it goes up and then comes back. So just something like this. Okay, and that's all I expect. Okay, you say, how do you know how high it goes? Maybe it shoots way up and comes down. Yeah, it might. We don't know how to do it now. Okay, you'll learn techniques from that in calculus. You know, where is that highest point or lowest point? Okay, 0. 0 plus 3, positive. 0 plus 2, positive. 0 minus 2, negative. So positive times a negative is negative. Three, positive, positive, positive. Positive times positive times positive, positive. Goes up, and there's no 0 after that, so it shoots to infinity. So that's it. That's the idea. Okay, so that's basically a style. Okay, let me show you some others. Okay, so again, from the directions, just graph. Never mind about what else it says. Oh, let's see. Some somewhat unusual ones, but how about I'll show you 37. 2 times x minus 1 times x minus 4 cubed. Okay, so they give us an exponent sometimes. 37 2 x minus 1 x minus 4 cubed. Okay, so what are my zeros? What makes this expression 0? Okay, 1 and 4. That's it, right? All right, we'll see what's the effect of this cube or squared or whatever. So we'll see. One, two, three, 4. 0 there, 0 there. One, two, 3. Okay, something over here, 0. Something between 1 and 4, well, 2. Something over here, 5. Draw a line to separate in this particular case. Okay, now 2 is already positive, right? If you're gonna multiply by 2, 2 is positive, so that's already a given, right? 2 times. Okay, 0. 0 minus 1, negative. 0 minus 4 is a negative 4. A negative cubed. Negative times negative times negative is negative. Okay, so what makes the whole thing positive times negative times negative? Positive. So this side it's positive. There are no more zeros to the left of this point, so it shoots up to infinity. Okay, 2. Plug in 2, that's positive. 2 minus 1, positive. 2 minus 4 is a negative 2. Cube it. Negative cube. Negative times negative times negative. Negative. 2 positives and a negative. Negative. It goes down. How far down, I don't know, but we don't care right now. 5. 2 is positive. That plus and that plus and that plus are for the 2. I mean, 2 is positive, right? That never changes. 5 minus 1, positive. 5 minus 4 is 1. 1 cubed is still 1, positive. Positive times positive times positive, positive. It goes up. There's no more zeros after that. Goes to infinity, like so. Okay. Okay, how about I show you just a couple more, and then maybe that's about it. 39. X plus 1 squared, x minus 1, x minus 3. X plus 1 squared, x minus 1, x minus 3. Okay, so get the zeros. What makes this 0? Negative 1. Positive 1. Positive 3. Right? -1, 1, 2, 3. -1, +1, +3. 0, 0, 0. Okay. Okay, pick something here, 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 here. And I reached the bottom on my paper. Unfortunately, I got to go back up. But how about, let's see, -2, 0, 2, and 4. Okay. So region 1, 2, 3, and 4. -2, 0, 2, 4. -2, 0, 2, 4. Let me write the expression again. Okay. And -2, 0, 2, and 4. Now, here's something that will save a lot of work. What do you notice about x plus 1 squared? Anytime you square an expression, it's positive, right? Unless you plug in -1, which we're not doing. So automatically, this first spot, they're a positive, aren't they? Doesn't matter what you plug in. Behind my pen, it can be positive or negative. You're squaring it. So these are all positive, right? So save work there. Okay. Now, how about these? -2 minus 1, negative. -2 minus 3, negative. So positive times negative, positive. So over here, positive, there are no more zeros to the left of that. So shoot to infinity. Okay. 0, I know that's positive. 0 minus 1, negative. 0 minus 3, negative. So same chart as over here, right? Positive times negative, positive. So region 2 is positive. So it goes up and comes back down here. How high up? I don't know. Okay, 2. I already know that's positive. 2 minus 1, positive. 2 minus 3, negative. Positive times negative, negative. Goes down. Get the idea? And finally, 4. We already know that's positive. No matter what I plug in here, it's positive, right? 4 minus 1, positive. 4 minus 3, positive. They're all positive. If you multiply a bunch of positives, positive. So this is positive, and there are no more zeros to the right of it, so it shoots to infinity. So there's the graph. Okay, so that's the idea. All right, one more, 12:35. Yeah, we're good. So I'll just do one more, then I'll give you something to do in class and we're done. And then I would be done with a section. So I'll just do 43 and I'm right on par for schedule-wise. Okay, so tomorrow, 4.7, and I'll give you a quiz at the end. It's also going to be on parabolas. And what I'm giving you today is also on parabolas. Okay, so the last one, 43 perhaps. Okay, so -4x, x minus 2 squared, x plus 2 cubed. Okay. Y equals -4x, x minus 2 squared, x plus 2 cubed. Okay, so let's get our zeros. So I can get myself untangled here. Okay, what gives me 0? 0, 2, -2. Okay, that's not too bad. Okay, what makes this 0, 0? What makes this 0, 2? What makes this 0, -2? Okay, so 0, 2, and -2. One, two, three, 4 regions. Region 1, -3. Region 2, -1. Region 3, 1. Okay, how come I'm not writing it over here like I did a long time ago? Well, it's because the graph might get it all cluttered. So I'll just leave it to you thinking, okay, that's region 1, 2, 3, and 4. But if I write it and then I draw the graph there, right, it kind of gets all cluttered up. So I trust you know, we're just going from left to right, region 1, 2, 3, and 4. And region 4, how about 3? And yeah, let me rewrite the expression. Y is -4x, x minus 2 squared, x plus 2 cubed. Okay. Aha. Once again, I can tell right away one of these expressions is always going to be positive. Can you tell which one it is? The squared term, right? Anytime you square something, it's going to be positive, unless you plug in 2, which you're not allowed to do. Not true for a cube, not true for that. But right now, I can just automatically go plus, 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 right? These are all going to be positive. Okay, -3. -4 times -3, positive. -3 plus 2, -1. Cube it, it's still -1, so it's negative. Positive times negative. Negative. Negative here. There are no more zeros to the left of this point, so it shoots down toward -infinity. -1. -4 times -1. Positive. We already know that's positive, right? Because of the square. -1 plus 2. 1. Cube it, still 1. 3 positives. 3 positives gives me positive. That means it goes up. 1. -4 times 1. Negative. That's positive. 1 plus 2 is 3. 3 cubed is positive. Negative times positive times positive. Negative, right? Did I do that right? Let me think about what I did here. Yeah, I think we're good. So it's negative. So it goes down. And then what happens over here? Does it go up or down? Okay, 3. -4 times 3, negative. We already know that's positive. 3 plus 2 is 5. 5 cubed is still positive. So negative times positive is negative. Goes down. There are no more zeros after that, so it shoots down to -infinity. So there we go. And that's it. All right, I'm done, folks. So I'm still able to keep up the schedule. So it looks like we are here. Okay, so on schedule tomorrow, 4.7 and our next quiz. And the exam for the following Thursday is only chapters 3 and 4, even though I'll get started with some of chapter 5. Okay, so any questions right now? Otherwise, I'll give you an in-class assignment and then we can call it a day. Okay, so I'll stop quickly, see if there's anything in the chat. I don't see anything yet or any questions. Okay, so you probably want to take a picture of this or you can write it down. It has to do with parabolas. Okay, so type your answer in the chat and you can leave. So take a picture on your cell phone or screen share. Okay, just tell me where's the vertex? Y equals negative x squared plus 8x. The formula you want to use is the vertex is at negative b over 2a. Give your answer as an ordered pair, x comma y. So here's an example of how you write your answer. This is not the answer, okay, but that's how I want you to type it, 3 comma negative 10, for instance. Obviously, I'm not going to give you the real answer, but that's how I want you to answer it. Okay, so y equals negative x squared plus 8x. Just tell me where's the vertex. Here's the formula. Should be pretty straightforward. So find the x, plug in to find the y, and type your answer, and then you may leave. Okay, I'll hold this just for another 10, 15 seconds. So please take a picture on your cell phone or screenshot. Any questions, you can put it in the chat. You can ask Star or me. So y equals negative x squared plus 8x. Give your answer as a point, ordered pair x comma y. And you know the formula is x is negative b over 2a. All right, I will assume you have it now, but I'm going to go ahead and type it in the chat also in case there's anybody that didn't quite get it. Okay, so I will stop the share and I'll stop recording.